Let us look at how to arrive at an equation of a conic in polar form. Remember, conic means a circle or an ellipse or a hyperbola or a hyperbola. So we want to arrive at a general formula in polar form. So let's begin with a parabola C. Okay, so C is a conic. S is the focus of the conic. ZZ prime is the directrix. So let's mark ZZ prime. Now SA is the axis of C, perpendicular to ZZ prime, intersecting ZZ prime at A. So let's draw the axis and let's mark A. L is the length of semilatus rectum, SL. So how do we arrive at this? We draw a line through S parallel to the directrix. And now we take the intersection of this line with the conic L, L prime. Now L, L prime is the latus rectum. Semilatus rectum is half of it, that is SL. So now we don't really require the entire line. So we will just join SL and get rid of this line. Now P, let's take a random point on the conic. So SP is the radius vector. Here S is the origin or the pole. So let's draw the vector, radius vector R. Now the angle of the radius vector with respect to the axis is theta. So let's mark theta. Now PM perpendicular to ZZ prime. Now we don't have PM. Let's draw PM perpendicular to the directrix ZZ prime, where M is a point on ZZ prime. Now PN perpendicular to SA, that is the axis, where N is a point on SA. So we have to draw a line PN perpendicular to SA. So let's draw PN. Let's mark this as N. Now LM prime perpendicular to ZZ prime, where M prime is a point on ZZ prime. So just like PM, we draw LM prime perpendicular to the directrix. Now we have got the construction in place. Now here the ratio of SP to PM is equal to E, the eccentricity of the conic. This can be written as SP is equal to E times PM. Yes, but PM is equal to AN. So that means it can be written as SP is equal to E times AN or NA. NA can be written as SA minus SN. So SP is equal to E times SA minus SN. Similarly, SL divided by LM prime is equal to the eccentricity. This is based on the definition of a conic. Now SL by SA, SL by SA is equal to E. How? Because here we have said SL by LM prime equal to E. LM prime is equal to SA. So we have done the substitution. SL by SA equal to E. So now we can write SA is equal to SL by E. So we rearrange this. Now SL we have said is L. So L by E. So SA is equal to L by E. Now since SP is equal to E times SA minus SN, we can write R is equal to, why? Because SP is equal to the radius vector R is equal to E times SA is what? L by E. So L by E minus Sn is r cos theta. Sn, theta is here, Sn is here, it is an adjacent side, right? So Sn by r is equal to cos theta. That means Sn equal to r cos theta. Now we need to, rearrange this a little bit. So let's open up the bracket. R is equal to, multiplying these two, we get E getting cancelled out. We are left with only L minus E times R times cos theta. This can be written as L is equal to R plus E times R times cos theta. So that now we have L by R is equal to 1 plus E cos theta. So what have we done? We have divided throughout by R. So we have L by R is equal to R by R is 1 plus E times R times cos theta by R. R gets cancelled. We are left with E cos theta. And now solving for R, we get R is equal to L by 1 plus E cos theta. Now this is the general equation of a conic in polar form. Let's see how it maps to circle, ellipse, parabola, and hyperbola. Now, if E is equal to 0, then what happens? E cos theta becomes 0. Only 1 is left. So L by 1 is L. So R is equal to L. That means L becomes constant, equal to the radius vector. So which implies C is a circle. If E is equal to 1, R is equal to L by 1 plus cos theta, which implies C is a parabola. Now, if E is less than 1, R is equal to L by 1 plus E cos theta gives us an ellipse. And finally, if E is greater than 1, R is equal to L by 1 plus E cos theta gives us a hyperbola. So we have arrived at a general equation using which we can arrive at a circle, parabola, ellipse, or hyperbola. So this is the equation of a conic in polar form. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.